Now we will have a look at changing bases with logarithms. So we've already looked at some examples in the previous video of equations with logarithms, and I showed you a couple of different examples where we were using our rules to change it from a logarithmic equation into an algebraic equation and then solving the algebraic equation. But the thing is, in order to use any of those rules from the previous video, you have to have the same base. So you will notice in all of those questions from the previous video, we always had the same base. Back here, we can see that we have some logarithmic equations, but you'll notice that now we've got different bases. All right, we've got different bases on the logs, and we cannot really use any of those previous log rules if you have different bases. All of those rules were designed for having the same base. So what we have is we have this formula or a rule or a law that tells us how to change the base of a log. And you can see it here, log to the base a of x, log to the base a of x. If I want to introduce a new base, let's say I would say some random base b, and I rewrite this, it will become log to the new base of x over log to the new base of a. So I think this is probably easier explained with a small example. Let's say I had log to the base 3 of 7, right? And for some reason, I didn't like 3 as a base. I prefer 5 as a base. So I want to change this and introduce base 5. So following this rule here, I'll get log to the new base 5 of 7 on top of log to the new base 5 of 3. And the 7 I got from here and the 3 was the old base. So the first time you look at this rule, it seems a bit difficult or a bit unfamiliar at least. But it is quite a straightforward rule. And once we do a couple of examples, you're going to see how straightforward it is. So the best way to get through this is to have a look at a question where we need to use it. So the question I'll do for you guys is this question 21 part B here. Log to the base 3 of x equals log to the base 9 of 5x minus 4. So taking that with us to the next page here, log to the base 3 of x equals log to the base 9 of 5x minus 4. So we're going to use this rule that we just looked at in order to change one of the bases so we have the same bases. I think it usually works out easier if you change the bigger base to the smaller base. So I'll leave this one as base 3 and I'm going to change this term here so it contains a base 3. So the first term will stay as it is. This will be left alone. Log to the base 3 of x equals, and now I'm going to use this log rule. So I'm going to change the base. So instead of calling it log to the base 9 of 5x minus 4, I'm going to call it log to the base 3 of 5x minus 4 on top of log to the base 3 of 9. So I've transformed it from this format to this format by changing the base using that law or that rule that you see here. Now after you do that, on top of the line I've got log to the base 3 of 5x minus 4. On the bottom of the line I've got log to the base 3 of 9. Now remember, log to the base 3 of 9 is a number. And by this stage you should know in your head what that number is. But in case you don't, let's just have a quick look at it. Log to the base 3 of 9 is a number. What number is it? Let's put it equals to x for a second. And remember, 3 to what power would give you 9? 3 to what power would give you 9? Well, you know that 3 squared will give you 9. So that means your x must be 2. So in other words, the value of log to the base 3 of 9 is 2. Because 3 to the power 2 will give you 9. So when you see log to the base 3 of 9, I can now simply call that 2. So rewriting this equation then, log to the base 3 of x equals log to the base 3 of 5x minus 4 over 2. Now once you're here, you just react to whatever you have in front of you. So we've changed the base has been changed. So now we have a logarithmic equation just as you had in the previous video. So now I just use whatever skills I have in order to solve this logarithmic equation. So the next thing I'll do, because I've got this 2 below the line, is I'll multiply the whole line by 2. So the next line will be 2 log to the base 3 of x equals log to the base 3 of 5x minus 4. Bringing that with me to the next page here, 2 log to the base 3 of x equals log to the base 3 of 5x minus 4. Now we know the next thing I'm going to do is bring this 2 up as a power on the x. We've looked at that rule already in the previous videos. So log to the base 3 of x squared equals log to the base 3 of 5x minus 4. And then to finish it, I just look at my balance. Remember, we have an equals to sign here. So what's on the left must be the same as what's on the right. So I know that log to the base 3 and log to the base 3 mean the same thing. So therefore, if these two sides are equals to each other, x squared must equal 5x minus 4. So you can see I'm getting an algebraic equation here, a quadratic equation. X squared minus 5x plus 4 equals 0. And then solving the quadratic equation, x minus 4, x minus 1 equals 0. So you'll end up getting two solutions, x is equals to 4 and x is equals to 1. So we're pretty much finished, but don't forget we have to check our solutions in a logarithmic equation. So we had this equation here, log to the base 3 of x equals log to the base 9 of 5x minus 4. And we had our solutions, x is equals to 4 and x is equals to 1 here. So we're going to check each of these solutions, x is equal to 4 and x is equal to 1, to make sure we're not getting the log of a negative. So if I use x is equals to 4 and I fill that into the original, I'd have log to the base 3 of 4 equals log to the base 9 of 5 times 4 minus 4. So that would be log to the base 3 of 4 equals log to the base 9 of 5 times 4 is 20, take 4 is 16. So you can see here we're not getting the log of a negative, so that means x equals 4 is an okay solution. And we must do the same check with x equals 1. So log to the base 3 of 1 equals log to the base 9 of 5 times 1 minus 4. So log to the base 3 of 1 equals log to the base 9. 5 times 1 is 5, take 4 is 1. So we're just checking we're not getting the log of a negative here. So that means x equals 1 is also a viable solution. We'll take a look at another example here. So the example I'll do for you this time is this question 22a. 6 log to the base x of 2 plus log to the base 2 of x minus 5 is equals to 0. Okay, so let's write it out here. So 6 log to the base x of 2 plus log to the base 2 of x minus 5 is 0. So once again, we're going to be using this change of base rule that we've already used. This rule right here, we're going to be using it because we have a base x here and a base 2 here. So we have to understand that we would like to have the same base in order to be able to continue with this equation. So what I like to have a number as a base. So I'm going to leave this one as base 2 and I'm going to rewrite this one, and instead of having a base x, I'm going to change it to having a base 2. And I just have to keep an eye on this rule here to make sure that I do that correctly. So let's rewrite this one. So 6 just stays as 6. Now log to the base x of 2, I want to rewrite this. So that will become log with the new base 2 of 2 over log of the new base 2 of x. So I just transformed it from this term to this term using this change of base rule that we've already looked at. The rest of it will remain the same. The rest of the equation is unchanged. So plus log to the base 2 of x minus 5 is equals to 0. Now, log to the base 2 of 2. All right, log to the base 2 of 2. That has a numerical value. Log to the base 2 of 2. What's that equal? So that's a fairly straightforward one. 2 to the power of what will give you 2? Well, you know that 2 to the power of 1 will give you 2. So therefore, x must be 2. X must be 1, I should say. X must be 1. 2 to the power of 1 will give you 2. So the numerical value of that right there is 1. Okay, so if the numerical value of that is 1, then you've got 6 times 1. So on top of the line, you've got 6 times 1, so that's simply 6 over log to the base 2 of x plus log to the base 2 of x minus 5 is equals to 0. So we still have logs hanging around. This is still a logarithmic equation, but at least now we have the same base everywhere. So it's an equation that has fractions in it. So I know to get rid of fractions, I multiply by the denominator. So I'm going to multiply the whole line by log to the base 2 of x to get rid of the log to the base 2 of x below the line. When I do that, when I multiply by log to the base 2 of x, I will get 6 plus log to the base 2 of x to be squared minus 5 times log to the base 2 of x is equals to 0. So I've gotten rid of my fractions, and now I have a logarithmic equation all on one line. So continuing this, I'm going to rewrite this a little bit. I'm going to put this term first. I'm going to write it as log to the base 2 of x to be squared minus 5 times log to the base 2 of x plus 6 is equals to 0. Now, hopefully at this stage you recognize this format. I've got a term squared, then 5 times that term plus a constant. So this format right here looks very like a quadratic equation, but I have these logs, in it. So it's a bit more confusing, but it still is a quadratic equation format. So I'm going to make this equation easier to deal with by using a substitution. I'm going to substitute in y anywhere I see a log to the base 2 of x. That's what I'm going to do. Sub in y for log to the base 2 of x. And then I rewrite this equation as y squared minus 5y plus 6 is equals to 0. So what I've done is I've just transformed the variables to make this a little bit easier to solve, or change it from a log to the base 2 of x simply to a y. So I've subbed in y for log to the base 2 of x. So then I can solve this simple quadratic equation, y minus 3, y minus 2 is equals to 0. So I end up getting y is equals to 3 and y is equals to 2. So I have my solutions. As I said, y is equals to 3 and y is equals to 2, but they're not the final solutions. They were just the solutions of this green equation that I have here. Remember, whatever you sub in, you have to sub back out to finish. So I sub in y here, so I need to sub back out y in order to get my final correct solution. So y was in fact log to the base 2 of x. Don't forget that. Y was actually representing log to the base 2 of x. So if y is equals to 3, that really means log to the base 2 of x is equals to 3. And if y is equals to 2, that really means log to the base 2 of x is equals to 2. Now, I actually have to solve for x. If you go back to the equation, the original equation, there was no y's. So looking at this equation, it's x we have to solve for. So telling me that y is 3 and y is 2 doesn't help me. I want to know what x is. So that's why we have to finish it here. So to finish it, we can use our transformation from log form to index form. On the left-hand side, 2 to the power 3 equals x. So in that case, 8 is equals to x. And on the right-hand side, 2 to the power 2 equals x. So in this case, 4 is equals to x. So this particular log equation had two solutions. X was equals to 8 or x was equal to 4 are both viable solutions. So that is our introduction to changing bases in logarithms. So we looked at the rule here. The best thing for you guys to do now would be to have a look at these questions, check your solutions, and for access to questions, solutions, graded quizzes, and more, visit www.logarithmic.com.